Hello! Today we're going to look at trim sheets. What trim sheets are, how they're made, how they're applied. So let's get started. What I have in front of me is basically a modular system piece that has been applied with a trim sheet. A trim sheet that looks like this. So this is a texture pack basically, or a texture set that has been extracted from a modeled detail set. And then once again, as with the high poly, low poly process, we are applying all of the geometric details in the shape of normal maps and ambient occlusion maps and curvature maps and even height maps to a flat plane of texture. We are covering it, we are applying it with a sort of like a stone texture, adding all of the nitty-gritty details and then exporting it as a material, which in turn will be covering the area, covering the UV range of a model such as this. Okay, we're going to be UV unwrapping this model so that it can receive the trim sheet texture, and when finally we are ready to put it inside a game or render it out of Substance Stager, it looks something like this with all of the height map details. But as a matter of fact, there are no geometric details on this thing, which is in actuality we have modeled. Okay, but these textures or these geometric details, as you can see, doesn't appear over here. This is a flat texture, but we are projecting all of this information first onto a texture, and that texture is then creating all of that geometric detail on a flat plane. And I'm going to show you how. Okay, so in Maya, we have a set of models, and these models, well, I'm not going to show you how to make them because, you know how to model these stuff by now, but it takes a certain amount of time, that's guaranteed. But in the end, the basic idea behind creating something like this is to, especially if it's slightly organic or handmade, like a stonework might be, an ancient stonework or a medieval stonework or whatever, or even if it is a bunch of concrete blocks, you will still want to first of all generate the basic shape of the model, something like so. Okay, pretty straightforward, a bunch of polygons, a bunch of simple polygonal pieces or simple solid geometry, and then you want to convert this to a far more advanced, far more dense mesh by retopologizing it like so. Okay, and after you retopologize these things, instead of trying to export this simple mesh and create normal maps or height maps out of it, you want to export the retopologized version, obviously. And also the retopologized mesh gives you the ability to sculpt additional details if you want to. Now, in my model so far, I don't have any sculpted details. The only thing that differentiates these meshes from the originals is that the latter is the retopologized version. So they are incredibly high resolution, but not necessarily incredibly, like, let me select everything. It's about 2 million triangles or 1 million faces, which might seem a lot, but if you think about processes like ZBrush allow you to go through in modeling these things, 1 million faces isn't a lot, but it is considerably high, and it's high enough to extract normal map details out of. Okay, but if you want to further add some details through sculpting into these things, go for it. But simple retopology is sometimes more than good enough if you want to especially extract geometric details out of these things. And remember, you don't always have to, because adding procedural textures on top of this in the Substance Painter will also help you get those details without having to model them. But what I mean by retopology adding organic details is exactly this. If you look at all of these models, they are slightly broken, slightly misshaped, slightly, asymmetrical. And that is because of the retopology process. Retopology gives you these types of bumps and creases in small amounts, granted, but it adds that level of naturalness to the model itself without you having to go in and add those details by hand. Okay, so the other thing that you should care about when creating these types of trim sheets is that you have to be very aware of how much area you're covering for all of your trim pieces. Now, for example, I have this piece and I know for a fact that it covers an exact area in thickness of 40 centimeters, okay? And every time it repeats by 1 meter increments. And this is an area of 2 meters. Now, it looks like it covers more area than it should, and that is by design, because remember, we're going to create tileable textures out of this thing. So whenever it needs to tile, we have to repeat the model itself, repeat the geometry itself onto the other end so it tiles perfectly. So this piece and this piece is exactly the same, and it appears on either end of this thing, so that whenever we extract those geometric details as projections onto the surface, whatever small details we might be missing here is already covered by the other area. Okay, so that's the main purpose here. Okay, but if you look at the normal plane that we're going to use to project onto this thing, it's this 2 meters by 2 meters. And now that's entirely up to you, by the way, how large of a trim sheet you are creating, or how large of an area your trim sheet will correspond to in terms of units. That's entirely your decision. It could be 1 meter by 1 meter, it could be 4 meters by 4 meters, it could be anything. It is entirely up to you, but know your numbers, know your dimensions, know how much of an area your trim, the individual segments of your trim sheet will cover in the end. So I know that this area covers 40 centimeters, this area covers 25 centimeters, this covers 5 centimeters, this covers 10, this covers 25 again, and this entire set of bricks or stone blocks, they cover an area of 1 meter by 2 meter. Okay, but when you get into the individual pieces, this block is repeating over and over again. None of these blocks are any different from any one other stuff. It's easier to model them this way because you can simply model one of them, retopologize it, and then copy the duplicate the retopologized version over and over again. And should you feel the need to add further details through sculpting, you can sculpt each of them individually. I'm not going to, create one whole big thing and retopologize it with 1 million polygons. That's first of all going to take a really long time, and second, that's not necessary, and in the end you're not going to get a better result anyway. Okay, so there you go. I have created my trim sheet geometry. Now I have to group all of these things. As you can see, I have done that, and I'm going to export it. And one other thing, once again, you have to make sure that the normal plane, the flat plane, the very simple geometry that you're going to be projecting these details onto, covers an entire area of UV 0 to 1 range. Okay, the entire UV range is covered with this normal plane. That's 2 by 2, 2 meters by 2 meters, and the geometry itself covers that entire area, and they appear on top of each other, as you can see. Okay, there you go. Now I'm going to export these things, which I already have. So let's go to Substance Painter and start texturing. I'm going to simply create a new file. okay? And in this case, I'm going to get a really high document resolution. This is a trim sheet after all. It's going to be a master material of sorts. You can always downscale the resolution later on, but at first I want to begin with the highest resolution that is available to me, which is going to be 4096 pixels or 4K resolution, okay? And I'm going to once again select the normal plane, in this case normal plane large, which is 2 meters by 2 meters in my case, okay? I'm going to select the flat plane as my object, as the object that is going to receive all of those projections. I'm not using UV tile workflow, blah, 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 using the standard PBR metallic roughness. Hit OK. Let's save this and let's begin anew. Okay, once again, let's go to Bake Mesh Maps, all right? And once again, as high definition mesh, in this case, I'm going to select my trim sheet. This is the exported geometry, which is this trim sheet group. Okay, let's select that. Okay, now the red areas are obviously not going to be included. The projection itself cannot see these red areas, but I don't care about this. I only care about the texture repetition points right around the edges. That's why I have repeated these geometry all the way towards the edge, so that I get perfect continuity, perfect tiling with the texture itself. I check my frontal distance, rear distance to make sure I am receiving all of these details without missing on anything. Then I'm going to check out my output size. Now this output size is really important in this case because I either have to select 4K resolution or go even higher to get better anti-aliasing. But that's not necessary because I can also use anti-aliasing from here, and I'm going to select super sampling 16x, okay? This is going to take a considerable amount of time, not too much, but it's going to take some time. And I am doing all of these now, not just the normals, but all of them, because I'm going to also texture this thing as well. Not only use the normal map, but also do all of it and use it as a final texture, final material. Okay, let's bake the selected textures. As you can see, even with my workstation, it takes some time. Okay, getting normals, material ID, ambient occlusion, curvature, position, thickness, you name it. I'm getting everything. Okay, let's return to painting mode. And there we go. We already have a material which is covering an entirely flat plane with no detail whatsoever. And it is working, okay? So I'm not going to overcomplicate stuff. Let me delete this layer real quick and let me create a texture, the similar kind of texture you have seen in the beginning. I'm going to simply get a rock face. Okay, let's play around with its settings. I don't want these many holes. I don't want this many color variation, grain intensity, or crack intensity. I'm going to dial everything down, make it a little bit more subdued. Okay, and I'm going to name this stone. All right. So I'm going to make a copy of it with Control D, and this is going to be stone edge. And what I want to do here is change the color slightly, create a variation on the color. Let me create a variation on it first, like slightly darker, slightly more desaturated. That's what I want to do. Okay, this is much better. But in this one, I want to get even more desaturated and whiter, meaning that the edges will be scratched, they will be scruffed, and the fresh stone face, the inside of the stone almost, is appearing from underneath. That's what I want to simulate. Okay, maybe even more. Okay, why not? Obviously, since this is a 4K texture with lots of baked mesh maps on top, it takes a considerable amount of time to update it every time I make a change. That's the thing about working with 4K textures. It's really taxing on your computer, obviously. Now I'm going to add a black mask onto this thing, which will immediately remove the layer completely. It is fully transparent right now, so to speak. But then I'm going to grab some edge details. Okay, so for example, I can select the concrete edges, because concrete and stone behaves really similarly, because if you look at it, concrete is artificial stone with its chemical composition and with its material behaviors. Concrete is basically artificial stone. So basically I can use concrete edge details on stone as well. So I'm going to put it onto its mask. It's going to appear with a mask editor, like so. Let's play around with the settings, and the best way to do that is by alt-clicking on the mask, which will isolate the mask itself to show me which parts will be cut off and which parts will be revealed on the final layer. So let's go into curvature. Let's dial everything down just a touch. Okay, like so. Okay, let's introduce this texture as well, and let's decrease this texture, and let's add a bit of ambient occlusion as well. I may be subtracting it, I don't know, or using add sub. Okay. Maybe let's play around with the balance just a touch. Okay, let's assume that this is good enough. I don't want this to take too long. Okay, so let's alt click on the material itself, and you will see that the edges are slightly whitish as they have been scruffed. Okay, now let's also add a dirt layer. Okay, let's search for dirt. Now dirt comes with many different forms. If you're not isolating any one of these types of textures or types of imagery, you can see that there are material types of dirt, and there are then fractal noise generators, which are, or grunge maps that are kind of dirt-like. Okay, what I want to create is a dirt dry, and let's put it in here, and it's going to come with its own fill layer. So let's go into the fill layer first and decide on the color of our dirt, which is going to be something quite dark, like so. And I don't want to use the height channel. I don't want this dirt to have some height or heft into it, because it's going to matter. But I'm using the roughness. I don't need to use the metallicness, because nothing in here is metallic in nature anyway, so why bother trying to calculate it? But I'm using normal map, I'm using the roughness map, and roughness is going to be relatively rough, because think about it, dirt is rough, it doesn't shine, right? So base color, dark, roughness, a lot. Then let's go to the fill layer once again. We have a mask editor over here. Let's isolate it like so. Okay, let's go into the mask editor. Okay, we're using curvature, and we are not using edges but cavities. We want to fill these cavities with dirt. Okay, and let's once again create a sort of graph, and the ambient occlusion, let's turn it off first to see what's going on. Okay, or maybe instead of using the dirt dry, I should use dirt cavities. So let me really quickly delete this and add dirt cavities, because that's going to give me a better result, instead of trying to coerce another type of layer that doesn't give me the best results in the beginning. Yeah, this is going to be much better. So let's remove height and metal, use the very dark base color, and then crank up the roughness, and then go to the mask builder. There you go, this is much better. Okay, let's play around with the curvature. Okay, it is using the convex range, as you can see, and the concave as well, but we are not concerned with things right now because we are mostly using the ambient occlusion. Okay, let's get into this. Okay, so let's reduce the curvature by a lot. Okay, let's go into AO and play around with the range just a touch. I want dirt, but not too much. Oh, this is really good. Okay, and that's really good. Okay, let's call this dirt. And let's alt click on it again and see the result. There you go. Now obviously I can do a whole lot more on this thing if I wanted to, but let's assume that this is what I want and this is good. But are we ready to go? Unfortunately not yet. I want to see the results of my work, including the displacement map, including the height map. Now before we get into that, let's check out one important thing. If you go to dirt and stone, both of them, as you can see, the entire area is being covered with this thing, and we are using the UV projection itself in all of them, which means, and this is really good, this entire texture is tileable right now. Okay, if this projection is somehow broken and it's not tiling one-to-one, regardless of how small the impact of this image might be in the final result, you will see breakoffs in the tiling in the final result. So make sure that your UV projection covers the entire area, because once again, you want to tile this thing. Okay, this is a master texture. It is not generated for a single object, okay, but it is generated to be used on multiple surfaces all the way around your model, all the way around your level design. Okay, so with that out of the way, I want to see what the displacement will look like. I want to see the effects of the height map. But when we look at the height map, it is missing right now. There is no height detail, and that is quite normal, because if you remember, when we were baking the mesh map itself, we didn't select height. Because of that, I'm going to go here and deselect everything because I don't want to calculate them over and over again, but I'm going to select the height and bake that as well. And as you can see, it will get this height map. All right, now when we return to the painting mode, we can see the height map. Okay, but this height map right now isn't being applied to the material itself. This appears as baked mesh map data, but that data isn't then being made part of the texture that we are creating on top of this normal plane, so to speak. It is right now not being used at all. Okay, we want to use it. All right, and the way to use it, and the reason why we want to use it is, first of all, let me show you what height map does. Now, both the stone edge and the stone itself contains height data. Okay, that's part of this substance material node. All right, they come with height data. So if I go to the shader settings and increase the subdivision count a lot, and let's go to material, okay, and then check out what happens when I increase the scale. All right, now I am adding height data, or I am using the height data created by these stone materials and applying it on top of the texture. But as you can see, it is not very detailed. The geometry, you can clearly see the triangulations, and because this happens because the subdivision count of 32 isn't nearly big enough. And unfortunately, I cannot type anything higher in this area, like 128. I wish. It doesn't happen. Okay, this geometry, any geometry in Substance Painter can only be subdivided 32 times or 32 levels. Okay, now in order to incorporate any more detail onto this thing, or at least see the effects of it and see the effects of this height map channel, we want to import a mesh that is considerably denser than the original one. Now let's go back to Maya and let me show you what I mean. If we go to the original normal mapped 2x2, this is what we got, a single face, that's it. But I also have this one as well. As you can see, it has already been subdivided by simply smoothing it, like 5 or 6 levels, if I remember correctly. And the good thing about this is that you can just create a single face and then you can subdivide it however many times you want, and the results will be automatically applied to the UV space as well. This is quite important. You want to get these details. You want to get the distance between these grids, so to speak, as accurately as possible. And if you do that automatically using the Maya's smooth function, they will be automatically done for you. Okay, so this is the proverbial high poly version of the same mesh, and I have also exported this one as well. So let's go back to Substance Painter, and instead of using this extreme low poly version of a flat plane, let's use a unnecessarily, so to speak, high poly version of the same plane. So I'm going to go into project configuration, and from the file menu here, instead of the low poly version, I'm going to select the high poly version. Let's open, and you will immediately see the difference that makes. Now, granted, the scale is a lot right now. This is extremely exaggerated. So let's, make it 0.01 or something, but you can immediately see how that affects the surface, okay? But here's the thing, the height map itself, the height map of the original geometry isn't being made part of this displacement channel, okay? Let's make it so. So what I'm going to do is create a simple fill layer, put it at the very bottom, and I'm going to call this height. And what this is going to contain is only the height channel, nothing else. I don't want anything in here, okay? And for this height channel, I'm going to search for height over here, and as you can see, it's going to also show me the height map from the baked mesh maps for this geometry, which we have created here by creating the height channel. This is something we have done already, and I'm going to just drag and drop this onto here, and ta-da, you can immediately tell the difference. Okay, there you go. All right, now let's go back to the displacement settings from the shader settings, and let me crank this scale up to, I don't know, 0.15. Much better. Obviously, be careful when you're using the height channel or displacement in general, and this applies to literally everywhere, whether it's in Substance Painter or later down the line in a few minutes we're going to take this over to Stager and you will see. Doesn't matter. Whenever you're using it, know its limitations. You are driving the geometry outwards, you're protruding it, you're pushing the vertices outwards using the height channel data as your information, okay? That is how displacement works. So there is limitations to that. As you can see around the edges, if the amount you're pushing increases by a lot, you will basically start breaking the illusion. Now, this is acceptable because we are looking at a very small part of this model from very up close, okay? You're never going to look at this model from this distance, especially even if this is a first-person shooter game, but know the limitations, okay? Don't push it too hard, otherwise it's going to look really stupid. Okay, the second thing is, like any other channel in the layer list, because sometimes we forget about that. When we look at the layers, we are only looking at the base color specifically, but from this drop-down menu, you can arrange the blending of all of these channels independently. Not only you can do that, but you are meant to do that. So if you go to height, for instance, okay, now we are controlling the height channels of the dirt, the stone layers, and this height map separately. Now, granted, the dirt layer does not contain any height data, so nothing is going to happen here, even if I change its blending mode or opacity, but the same cannot be said for the stone materials because they have indeed height layers, and their contribution to the final height layer can be adjusted. So what I mean by that is that, for example, this is way too much, right? This is way too, let's say sharp and exaggerated. I wanna remove that exaggeration, so I'm going to crank them down to 50% opacity, and you can immediately see the effects. Okay, I am still getting really nice height data from those layers. I am adding a considerable amount of sculpted, so to speak, details onto this height channel, but not too much. Okay, and this is what I meant by not needing to not feeling the need to sculpt any details in Maya. The texture application process or the texture generation process in Substance Painter, if you play your cards right, can do that for you. As you can see, it would have taken me a considerable amount of time to generate all of these details, whether I do it in Maya or ZBrush, doesn't matter. But if all I'm asking for is a bunch of textured rock details, I can easily do that here as well, and it's going to look really good in the end. So with that, we are done. Let's assume that I don't want to do any more stuff on this texture. Okay, now I have to prepare my models to receive this trim sheet, and that takes a different kind of approach as well, especially in the UV texturing process or UV unwrapping process. Okay, so what I'm going to do is, after saving this, and let's save it as, I don't know, trim sheet 2, because I already have a version. Okay, we have saved this. I'm going to export the textures. Okay, and I'm not concerned with all of these textures, like the roughness, the metallic, normal, height, whatever. I'm not concerned with all of them. I'm just going to use one of them, and whichever one feels the easier to control or feels easier to see, you do that. Now granted, I am using a lot of dirt layer, a lot of stone details, and blah blah blah, so that I can visually understand the separation between the different parts of the trim sheet, but that's not going to be the case every time. Okay, sometimes you won't be able to visualize the separation lines between the different parts of the same trim sheet using the color channel. So in that case, you might want to use the height channel, or you might want to even use the normal map channel. Even though it seems counterintuitive, what we are about to do is just for visual purposes. Okay, we are not going to texture this thing in Maya. That's not the purpose. We are only setting up the UV space in Maya, and for that we need visual reference of which part of the trim sheet we are going to use and unwrap to. Okay, I'm going to use the color, but if color is not indicative of those details, use a different channel. That's what I'm trying to say. Okay, so let's export the this one and go to the output directory, and there you go, we have this color channel. And this is what I mean. If you get really close, you can clearly see the separation line between different parts of the trim sheet. That's perfect. But once again, not every time this is going to be this way in the color channel. Maybe the color channel is really flat and you will have to see those details in a different channel entirely. Okay, that's perfectly acceptable. Now I'm going to carry this over to Maya. Okay, and I already have one here. So stone color, this is the previous version. Basically it's the same thing, just small details, just small differences, but there you go. Okay, let's go into Maya. Okay, and let's hide this with Control H. Let's reveal this. Okay, the doorway. Let me make a copy of it. Let's put it in here. Let me hide these planes as well. Let's hide this, and let's freeze the transformation. Good. And then let me go to its UVs and delete the UVs. All right, and the other thing I'm going to do is just create a new material from the Hypershade, and you can access Hypershade from Windows, Rendering Editors, Hypershade, right here. Okay, this is the material editor for Maya. Now in here I have created a new Lambert, which is a standard type of material in Maya, Lambert 5. Let's right click on it and say graph network, so we see the entire shader network over here. And I'm going to first either middle mouse click and drag and drop this onto my model, or I can just select the model, right click on the material and say assign material to selection. There you go. And I'm going to also go into shading and turn on hardware texturing, so whatever texture I apply to this Lambert will appear here as well. Okay, that's also important. Now let's go to Lambert 5. Let's click on the icon next to the color channel and select file from here, because we are going to introduce our color file, color map. Okay, let's go to image name, click on the folder icon, go over here. Let me go to my folder structure, model to texture workflow, exports, textures, and here we go, we have stone color. Open, and there you go, it has been applied. Now since this thing does not contain any UV data whatsoever, it's not going to appear, it's going to only receive the flat color from this. Okay, now what we intend to do here is, first of all, let's turn this off. Or minimize it. We're not going to need it for quite some time. The first thing that we should be considerate about is that, well, this thing, the size of this thing. How are we, let's say, UV unwrapping this? What is going to be the textile density? Now, when we were creating our trim sheet, we were covering an area of 2 meters by 2 meters, okay? But if you look at this model, it covers an area of 4 meters in this direction and more than 4 meters in the Y direction. Okay? So what are the intentions here? Are we going to, make this object receive 2 meters of texture data for its 4 meters, or are we going to tile this texture repeatedly? Now, in my case, I'm going to tile the texture, meaning that the 2 meter by 2 meter texture will be tiled across the surface. Okay, so in that case, the textile density of the trim sheet that I have created originally and the textile density of this object will be exactly the same, assuming that we are using the same texture size. Okay, so let's calculate that. For example, we are using a 4K texture and we are showing an area of 2 meters by 2 meters, that is 200 centimeters in that area. So if I open up the calculator and divide 4096 by 200, I'm going to get 20.48 pixels per centimeter. That is the textile density. Okay, now I want to use the same textile density on this thing, okay, assuming that we are using the 4K texture pack. So in order to do that, we're going to do a couple of things. One, let's create a standard planar or planar UV mapping, UV projection, okay, something like this. And you can see the UV projection over here. This is the UV plane right now. Let's play around with it. First of all, we're going to assume the projection width is 200, okay? And then we're going to rotate this like so. All right. And you can clearly see, if I were to carry this UV shell over here, it is covering an area of 4 meters and slightly more than 4 meters in this direction, but whatever. Okay. And let's open up the UV toolkit. Let's go into 496 and get. It's not working as intended right now. Okay. But we'll make sure it works that way in a few movements. Okay. And the other thing that I want to do is that since I'm not going to UV unwrap this thing across 4 regions, and I want to UV unwrap it in a single region, instead of trying to, put this geometry across 4 regions, I want to instead tile this texture in a single region 2 times in both directions. What I mean by that is, check this out. If I go to this UV settings, the placement, so to speak, of this file onto any geometry, the UV settings, the texture placement attributes. And if I go to repeat UV and say 2 for both of them, you can clearly see that now the texture itself is repeating 2 times in both directions, in both the U and V directions. We are tiling this texture. So this is much more intuitive and much simpler way to texture any kind of object if your final intention in the game engine or elsewhere is to tile the texture 2 times or 3 times or 4 times or whatever. Okay, so we are UV unwrapping this thing with the intention of later on repeating the texture onto the UV projected area, the UV region itself. Okay, now this is going to make much more sense when we start actually unwrapping this thing, which we will do right now. Okay, now let's get the easy stuff out of the way. Let's break this object into various pieces wherever we feel is necessary. Okay. Okay, let's break it apart from this corner, break it apart from this corner. Okay, let's cut them. Okay, and check this out. I have prepared, let me turn off the hardware shade texturing so you can see. I have prepared these areas in advance. So as you can see, there are lines here, but when you look at it from a geometric perspective, why are there any lines in there? Like, there's no geometry in there. There's absolutely no need why an edge should appear in there. But the intention here is to be able to separate that part of that geometry as an independent UV shell, which then I can place wherever I feel like in my tile sheet. Okay, so it will receive a different part of the texture. Okay, and in order to do that, I have to create some edges which then I can cut in the UV unwrapping process. And that is exactly what I'm going to do. I'm going to, let me show you what I mean. Let's turn on hardware texturing. And if I cut along these lines and say cut, and let's grab this UV shell, check this out. Now I can place a different part of the same tile sheet on that surface. Okay, so that's exactly how this tile sheet is supposed to work. And the same is true for here as well. I'm going to cut these areas. Okay, I'm not going to cut these areas. Those are just there for edge continuity. They're going to be receiving a different part of the texture anyway. Okay, let's cut those areas. Let me cut these areas. Okay, nice. All right, I think we are good to go. Okay, so let's separate the UV shells just by eye. Okay. Oh, and then I want to cut these parts as well. Same deal. No, usually no need to cut them, but I want to project a different part of the texture onto them. Okay. And I also have these flat pieces as well. All right. This part and this part also, and these parts also. Okay. Now the problem with this is, for example, if I were to select all of this and now say 20.48, as you can see, they are exactly that size. Okay, but if I say 8192 and say the same thing, or break this in half like 10.24, they're going to be scaled to a state where now we can quickly place them onto this tile sheet, which are tiling 2 times in each direction. Okay, now they're at the correct textile density. All right, we'll get to that. But when we look at these stuff, as you can see, they are infinitely stretching because they have no thickness. Our projection plane, if you remember, our UV projection plane, the planar projection, was looking at them flatly or vertically from this angle. Okay, and because of that, they are infinitely stretched right now, so we have to unfold them. But there is something quite buggy with Maya's unfolding feature, which they still didn't fix. If I unfold them, they're going to disappear into nothingness because As a matter of fact, Maya is trying to divide by zero. It's trying to do a zero division operation, which is failing, and that's why these faces are disappearing. That's why in previous tutorials on all of these previous examples, whenever I created a planar projection, if you remember, I always gave it some weird rotations, like so. And this is why. Okay, so to prevent the zero division, I am rotating the projection plane in weird angles and then relying on the unfold feature to take care of it. Okay, so in this case, what I'm going to do is grab these edges once again, because now they are sewn back in. Okay, I'm going to cut them once again, separate the UV shells. Okay, now I'm going to select these UV shells and hit unfold. Okay, perfect. Let's orient them. We're going to further orient them later on, and let's set the textile density. Okay, now we are ready with all of our pieces to be applied to this trim sheet. Okay, and as we do, I'm going to be continuously checking the process over here. Let's start with simple things like this UV shell. I want it to be covered with the stonework area. Okay, let's put it in here. And similarly to your, the area in which you play around with the viewport, in the viewport with the geometry, you can always change the pivot position here as well. So I'm going to snap to this vertex, and by hitting, holding X on my keyboard, I'm going to snap to here. Now the important thing about doing this job is that making sure none of the vertices or none of the UVs, so to speak, these points, stick out of this UV region. At the very end, at this point exactly, the 0 point, that's fine. You stick it out of it, it's going to break. So later on we're gonna make sure that nothing sticks out by grabbing every vertex around the edges and snapping them to the sides just to make sure. But for now we're good to go. Okay, now we have put the UV shell in here, but as you can see, it is receiving the trim on the top. So I'm going to put it here so that it receives these texture work beneath here. Okay, right here. Oh, you can also snap it because I have prepared my model to correspond to the points that are already available in the UV region as well. So I'm snapping to the UV region, but take a look, it's also snapping to the exact texture that I'm creating as well, because I have prepared in advance. Okay, good. Now let's do the same for here, for example. Now if I place it here, let me hit insert and reposition my pivot and then drag it all the way over here. Or I can select both of them and say align to the one that is on top. Okay, but take a look. As you can see, the bottom portion right here, this area, isn't receiving the stonework anymore. Instead, it's receiving the texture, the part of the texture which is underneath it, which isn't very good for me. So in that case, I'm going to grab these edges and cut them, and then grab these UV shells, and maybe, I don't know, I can put them over here instead. And you can do this by eye as well, or let's not do this by eye. It takes a bit of patience. Well, we have to do it by eye. Okay, that's good. I mean, we are right down the center. Nobody's going to know. Okay. And yeah, it takes a little bit of patience and a little bit of preparation too. So as you can see, the distances in my model also correspond with the distances I know I will have in my texture as well, because that's the beauty of creating your own trim sheets. If you look at my trim sheet, like the distances are like, let's say the thickness, the height of each of these stone blocks is exactly 25 centimeters. So when I was preparing my model in here, I was deciding on these dimensions with the knowledge that I'm going to be applying 25 centimeter incremental brick placement. So everything in here is either 25, 50, 75 or 100 or so on and so forth. Okay, so when I UV unwrap them in the same textile density, in the same relative resolution, they match perfectly, because this part right here is exactly 75 centimeters and it's receiving 75 centimeters worth of texture data. Okay, so that's the power of the grid, that's the power of working with known dimensions. Okay, so let's hide this once again, Control H. Okay, let's go back. Okay, let's handle these areas once again. There you go. I have a line here that I'm going to use to break this object into two pieces, because the most amount of stonework I have freely available is only 1 meter tall. Okay, anything beyond it, I will have to break that object, break that surface apart using edges and cut those edges to create separate UV shells, which I will then have to separately place. This is exactly what's going on here. Okay, so I can, you know, just do an arrangement like this and grab these you know, edges, cut them, and then grab these UV shells. All right, and then, for example, align them to top like so, and let's pull them over here. Let's do an alignment like so. Let's do an alignment like so. Using the shells that we have already arranged, I am aligning to the leftmost one, the rightmost one, the topmost one, the upmost one. You get the idea. Okay, so then we're going to do something similar and do this. Okay, there we go. We have a problem. This thing should be aligned downwards, so let's grab these versions. Okay, and do this instead, and ta-da, it has worked. Now we have these areas. Okay, let's pull them over here. Let's make sure they're on the same level. Okay, let's grab this and grab this, do that. Grab this and grab this, do this. All right, and let's pull them over to here. Oops. And maybe we can even snap to one corner and place it like so. Exactly where I want it to be. Okay, good. Let's do the same for this shell, which is going to receive the top trim. Perfect. It already matches. Okay, there you go. And then finally, let's do the ones around the doors. Okay, so this and this. Let's make sure they receive the same texture. Okay, and this, let's get the one which is the symmetrical version. Okay, let's rotate it. And we have this one and this one. They will receive the same texture as well. Okay, and then we have this one which is on top, and this one which is on the bottom, and this one which is on the face. Okay, so let's do it. Let's first put this in here. Let's find the one which will receive the correct texture. Okay, this isn't receiving the correct texture, by the way. This should be towards the bottom, like so. Alright, but this one should be towards the top. Okay. Good. Let's pull this one, place it in the same place, using this one as a reference almost. And let's grab these and stack them. Since they are the same object, or let's say similar UV shells, they're going to be stacked perfectly. Let's make sure that they are oriented perfectly again. Okay, perfect. Let's stack them, orient them, make sure together, rotate it. Okay. Let's do the same for over here, stack them together. Okay. And let's place it over here. Perfect. Doesn't matter if the UV shells, are misaligned. As long as they are inside the UV region, it's not going to matter much. Okay. And let's put it over here. So let's go to our model. Let's check the placement of objects. So let me turn off the UV toolkit so we have more space. As you can see, this edge of the stonework and this edge of the stonework is not matching, so I'm going to grab these pieces, assuming that this face is the correct one, and I'm going to do this just to make sure that they match perfectly. Okay, let's go over here, make sure they match. This area matches and this area matches, and let's look at it without the edges. This is a bit wonky. As you can see, this area is a bit wonky. You can also do something like this, like grab these UV shells, and in order to escape from these creases, you can obviously stretch it like so. It's not going to matter too much if you don't overdo it. Okay. I don't think that was the problematic version. Let me check. Oh yeah, maybe it was. Maybe let's get all of these UV shells and just arrange their placement so that, yeah, that's what I wanted to do. Perfect. Okay. Everything's nice. I'd rather have these stonework, the end of the stonework matching this area, so let's fix that too. So let's go to UV shell. There's 3 of them. Perfect. Okay, so let's make sure these match as well. It takes a bit of time. Bear with me on this. Okay. I mean, it's a bit wonky right now, but that is an issue that we will have to fix later on. Let me show you what the problem is. So there we go. This area right now is covering a 20 centimeter area and is covering an area of 80 centimeter, which is outside the limit. So I have to break this apart like so. So if I go over here and say, oops, this area and this area covers an area of covers a distance of 1 meters. There you go. Now this is going to be getting the entire stonework, and then this will be getting the same thing again. So with this adjustment, slight adjustment, I have to go in to all of the affected UV shells and unfold them again like so. And obviously that is going to, you know, break some of the adjustments I have made. Instead of doing that, I can first of all do this like so, unfold them like here, set them to correct distance, orient them, okay, and let's, you know, orient them like so. Okay, perfect. Hopefully that has solved our problems. Let's grab them once again. Sometimes this doesn't work for some reason, because I have to select it from here, apparently. One of the Maya's quirks. Okay, let's make sure everything works perfectly. Okay, now I can go in and grab this 50 centimeter point or 100 centimeter point. Okay, so this is 100 centimeter worth of stonework. It's a bit of a brain teaser, as you can see. Okay, so I'm going to do this instead. So perfect. Now check out the perfect alignment. Same as here as well. Okay, perfect alignment, perfect alignment. Everything works. There might be an issue with this area, especially with the way this changed. This texture change creates some let's say these edges, they created some texture stretch, and you'll see what I mean once I grab all of the affected areas. This is the texture stretch I'm talking about. It's not much, it's not noticeable. What I'm trying to basically do is just reverse that effect, so to speak. It's not super important. Okay, there you go. Let's assume that's good. Okay, let's delete the history. We're finally good to go. Let's turn off the UV editor and the toolkit. Okay, now we have used our trim sheet to do our texturing, and our UV map for the object is arranged, is projected onto the trim sheet itself, the trim sheet that we are going to use in the end. Okay, now this is not the only way to use a trim sheet. You can also break it apart using during the shading process and use it with triplanar projection inside the game engine itself. But for today, I'm only going to show you this technique. And one final thing, let's get this to Substance Stager. Obviously, let's export this selection. Okay, I'm going to say this is doorway number 2, FBX. Okay, let's go into Stager. And let's create a new one without saving this. Okay, and I'm going to import, oh, not this one. I'm going to import the doorway number 2 over here. Include unused materials, generate UVs, blah blah blah. Okay, we're not generating UVs, we already have UVs. Okay, now it's going to come with its own texture which we applied in Maya during the texturing stage. Hold on, let me turn off ray tracing. Okay, good. Let's go to transform, make sure this is centered. Okay, nice. Now obviously this texture isn't enough. We are only using the color channel right now, and we use that color channel specifically to apply or to project the UV. So we need the real material this time. So I'm going to go into Painter. Okay, so instead of exporting these texture maps, which for a game application you will need to do that obviously, but in our case I can just go in to File and say send to Substance 3D Stager, and it will send that entire material set onto Substance Stager. Okay, and when we import it, here we go, we have a project material. Let's call this stonework, not SD gunwork, but stonework. Okay, and instead of using this Lambert 5 material, which we can delete, okay, we can apply the stonework. Now obviously this is wrong. Why is this happening? But remember, we were repeating the UVs 2 times in either direction, X and Y direction, or U and Y direction, U and V directions. So if we do this, this is going to perfectly work. Nice. Now we have textured, as you can see, our wall. Obviously we have a normal plane here as well, because the normal plane is also being important, and because the painter is not only importing the material, but it's also importing the object in which the material was applied to in the first place. But we can delete it. We only care about the material. Okay, then we want to see the effects of the displacement. For that we have to do a couple of things. One, we have to go into the object itself and open up displacement. Okay, and this is going to be allow much more subdivision than Painter allows. Okay, the other thing we need to do is go into material itself, because material also has a height map, which if you worked with the height map in Substance Painter, it's going to come in automatically, and we're going to be deciding on the height level. So let's go into object first and, you know, increase subdivisions. But in here we can go higher than that by total face budget instead of using the per triangle. And I'm going to go crazy in here and say 2 million. might take some time, but the effects will be noticeable. There is something wrong with this part right here. Okay. I'm trying to fix that area. That didn't happen before. Something wrong with the displacement. Let's see over the material. Maybe it's going to fix it if we play around with the height scale over here. Let's put it on the halfway mark, like so. Let's go into ray tracing. Maybe that problem isn't related to the object or the texture itself. Ray tracing will take considerable amount of time, but yeah, it's showing the same problem. It's probably something wrong with the stager. I don't think any of our materials or objects are problematic. Sometimes this sort of stuff might happen. I'm going to turn off ray tracing because it's going to, you know, push it really hard. But there you go. Forget about the error here. It's probably because of the stager. But there you go. You can clearly see that our displacement map is working. We have perfectly textured our object, and you can get all of that crazy detail from the rock face as well. But when you look at it from a modeling perspective, it is an incredibly simple, incredibly lightweight model with only 58 faces, sorry. 58 faces. And the good thing about this type of modeling and using trim sheets is that imagine this is just a single piece in a hugely complicated modular system with inside corners, outside corners, windows, differently sized doors, differently sized walls, differently sized anything, okay? And all of them are as low poly as this, and they are using the same flat trim sheet texture with height map detail. And in the end, if you correctly place their UE shells in the UE texture editor, like so, stack them however you wish, stack them however it is necessary, you can, using a single material, texture an entire modular system. Okay, so this is how you use trim sheets, and I'll see you in the next one.